Right. So what is big data? Big data refers complex or large data sets that cannot be processed by using traditional processing tools such as Excel and right SQL. Okay. Right. So coming to the third unit topics, already we have covered these topics. One more time, we'll revise the topics. Right. So the third unit about the syllabus is right. Introduction to Hadoop. Right. What is big data? Apache Hadoop ecosystem. Okay. So moving data in and out of Hadoop and understanding inputs and outputs of MapReduce data serialization. Okay. Right. So we have seen all these like what is big data, what is Apache Hadoop, and coming to Hadoop ecosystem. So what do you mean by Hadoop? What is Hadoop, Nana? What is Hadoop? Apache Hadoop is a open source framework which is used to store and process the data in a distributed manner. Okay. So storing and processing the data. The purpose is store and process the data in which manner? In a distributed manner. Okay. So the problem with the traditional tools, right? So we cannot store data in a distributed manner, right? So we have a single server. So in that server only we'll store the data. Basically, the data is structured data. Whereas coming to big data, we have wide variety of data, that is structured, semi-structured, and unstructured data. And this data is very huge, very large, right? So very complex data sets are there. So to store this data, right? So our traditional data storage systems are not suitable. Okay, right. So by using Hadoop, Hadoop is the open source framework. By using this framework, right, we can store and process the data in a distributed manner. Okay, right. So what are the right components of Hadoop? Basically, what are the core components of Hadoop? Right. So the components, the core components of Hadoop. Right. The first one is HDFS. So what is HDFS stands for? Right? Hadoop Distributed File System. We can also call it as parallel storage. HDFS is also called as parallel storage. Right. So how the data is stored in HDFS? How the data is stored in HDFS? Right. So basically the input files, the incoming input files, so these are splitted into blocks. Okay, all these blocks are equal sized. Okay, so what is the size of the block? By default the size of the block is 128 MB. The size of the block is 128 MB. So the input file is split into blocks, and these blocks, right, these blocks are stored across cluster of computers. Where exactly these data blocks are going to be stored? Where it is going to be stored? If you look at the HDFS architecture, right, so what are the different nodes are there in HDFS architecture? Right, one is name node, right? So second one is data node, right? The third one is secondary name node. So these are the different nodes are there in the right in the HDFS architecture. Okay, so we already know like name node will maintain all the metadata. Okay, and coming to data node. So what is data node? Right, where exactly? So these blocks, the incoming input file is there, no? So This file is split into, these files are split into blocks, and these blocks are stored in the data node. Okay, so exactly the blocks, where the blocks are going to be stored, in the data node itself. Okay, so what is the role of third one, secondary name node? Right, it will maintain the updates, like that is like nothing but checkpointing of data. Right, so what are the blocks are currently available, where the where exactly read and write operations happen. Okay, so that information is maintained by the secondary name node. Okay, right. So the first component is HDFS. This is used to store the parallel processing of the data. Whereas coming to what is the second component? What is the second component now? What is the second component of Hadoop? Right, MapReduce or YARN. Okay, the second component is, right, so YARN. Okay, the second one is YARN. So what is YARN? Right, so yet another resource negotiator. Yet another, right, resource negotiator. So the name is resource. So that means, so YARN is used for parallel resource management. YARN is used for parallel resource management. So what do you mean by resource? Right, that you have already learned in operating system, right? What is a resource? So if you take a your laptop or a desktop computer, right? What is resource? Resource example. Resource के example ఏంటన్నా ना? Right. So your CPU is one resource, because multiple process are executing parallelly. They are competing for the CPU. Okay. So if the CPU time is available, that process will be executed. Okay. What is the second resource? Memory. Right. So your memory is nothing but, basically if you see desktop computer, how many types of memories are there? What are the different types of memories available in a system? Right, primary memory and secondary memory. So primary memory is nothing but RAM. So here management resource, when we are talking about resource, we'll discuss about only that is primary memory, RAM. Okay, right. So next, third one, scheduling of jobs. Okay, so all these are like managed by, right, who will manage all these tasks? By using YARN. So that is the reason we call it as parallel resource management. Okay, right. So what is the next component? What is the third component? Map reduce. What is the third component? Map reduce. Okay. So what is map reduce? What is map reduce? Say parallel processing of data, right? That is done with the help of map reduce. Okay, so because Hadoop is used to store the data in a distributed manner and process the data in a distributed manner. So for storing we are using HDFS. Okay, so for processing we are using MapReduce. Okay, so what are the phases of MapReduce? Right, so map phase, and reduce phase. Map and reduce. Okay. So mapper, what is the role of the mapper? What is the role of the mapper? Right, it will take the data from HDFS. Okay, it will take the data from HDFS, and these input files, these blocks will be converted into, right, key value pair. So K stands for key and V stands for value. Key value pair. Okay. So this key value pairs also called as intermediate results. Okay. So the intermediate results are in the form of key value pair. Okay. So this is given as input to the reducer. So what is the role of the reducer? What is the functionality of the reducer? Right. So same key values will be, right, shuffled, sorted, and aggregated, and the final result will be produced. Okay. So the final result where it is going to be stored? Final result ekkada store aitadana, right? So again it is going to be stored in HDFS. Right. So map reduce, it will take input from the HDFS, and after all the processing, right, the final result again it is going to be stored in a, right, HDFS. Right. So these are the core components of, right, Hadoop. Okay. Now coming to Hadoop ecosystem, right. So what is Hadoop ecosystem? So Hadoop ecosystem is nothing but, like, it is collection of tools, right, so that work with the Hadoop framework. Okay, to handle big data. Right, Hadoop ecosystem is nothing but collection of tools, right, so that work with the Hadoop framework, right, to handle the big data. Okay, right. So what are the different tools of Hadoop ecosystem? Right. So Hadoop ecosystem is nothing but it's a collection of tools. So what are different tools? The first one is data ingestion tools. So what is the meaning of data ingestion? What is the meaning of data ingestion? Data ingestion and
Hey,
ఏంటన్నా?
silence. Okay.
Right, inserting data into the, right, Hadoop, HDFS. Okay, data ingestion tools. Next, storage. Okay, so how to store our data? Like processing. So once the data is stored, we need to process the data. How the processing is done? By using MapReduce, like querying. Okay, so we want to retrieve some data from the
Okay. So
HDFS.
what is Hadoop?
Okay, right,
Hadoop
we'll
is
write
an open
some
source
queries. For example, if you
technology
are
that
using
is used
SQL,
to
right,
store
there is
the
a
large amount
table
of the
called
data,
employee. Okay, so we
which
want to
is
retrieve all the
processing,
data related to employee names.
which is
Okay,
processing and
employee names
store
who
in
are
the
working in some X
large
company.
amount of the data,
Okay, so what is the query? How to write the query? Select, select, like ename, employee name, from table name, right? So let's say the table name is, let's say, employee. Okay, so we'll retrieve all the data, right? The output is in the form of table which consists of all the employee names. Okay, right. So like this we'll use the queries. So whereas coming to big data, here we are using NoSQL language, right? So no SQL language, because the data is in the form of, right, it consists of structured, semi-structured, and unstructured. So our traditional SQL programming language is not suitable, okay, to query the data.
Hadoop.
And
Hadoop
the
is a
final one
open
is
source technology
analytics.
that is used to
Okay,
store.
after
large amount
processing
of
the
the
data,
data,
right, we want to analyze the,
which is
we want to draw some meaningful insights. We want
in
to
a
analyze the
distributed
data.
and
So
parallel
that
manner.
can be done with the help of
Okay,
some
Hadoop
tools.
is an
Okay.
open source technology that is
So
used
coming to the
to
major
store the
components
large
that we have
amount of the
already
data
discussed.
in a
The first one is
distributed and parallel
HDFS.
manner.
HDFS is
Okay,
nothing but
so in a
parallel
in a
storage.
Hadoop,
Okay,
we have
right.
two
So these
important
log
technologies.
files,
Two
basically these
important
are
technologies.
stored
One
in
is the
across cluster of
HDFS.
computers,
Second one is the
and the
MapReduce.
file is divided into set of blocks,
One,
right?
two
So,
important
and
technologies.
it is
One is
optimized for
HDFS.
high
Second one is the
throughput,
MapReduce.
right?
So
Fault
HDFS
tolerance
stands
and
for Hadoop
scalability.
Distributed File
Okay.
System.
So high
And
throughput means what,
so
Nana?
here
What is throughput?
HDFS is the primary storage. HDFS
What
is
is
the
throughput?
primary storage.
So, like in OS,
And
you
in
have used this term
HDFS,
called throughput.
there are three important
What do
concepts
you
are
mean by
there.
throughput?
In HDFS, there are three important concepts are there. One
Right,
is
the
the
number of processes which are
what is
executed
the
in a unit
first
time
one?
within a given
Block
time is
size.
called throughput.
Block
Throughput time
size.
should be maximum or
Second one
minimum.
is the name node, and third one
Throughput
is
time
the
is
data node.
maximum or minimum. For
So
example,
these
you are
are the three
evaluating
important
process
concepts we
scheduling
have in
algorithms.
HDFS,
Right.
Hadoop Distributed File System.
So throughput time
Block
అనేది
size,
ఎక్కువగా ఉండాలా
name node,
తక్కువగా ఉండాలా?
data node. Okay. So block size, the block
Minimum.
by
Okay.
default the block
Right.
size
So in a
in
minimum time,
HDFS is
right?
128
So the
MB.
process must be
Okay.
executed.
But
So process
by
should take
default,
only less time to
the
for
block
its
size
execution.
in HDFS is
Okay.
128 MB.
Right. Next
Okay.
to fault
In normal
tolerance.
operating
What is
system,
fault
the
tolerance?
block size is 4 KB.
What
Okay,
is fault
8 KB
tolerance?
like that. But in HDFS, the default block size is 128 MB. The default block size is the 128 MB. So, for
What is
suppose
fault
here
tolerance?
I
The
want
day
to
one
store
నుంచి చెప్తున్నా, right?
520 MB of data.
We are using
520
this
MB
term
of the data.
from the day one.
Okay.
The
So
BDA
this
class
is
is
the
started.
block. This is the block.
Right.
Now,
So because
this
the data is
520
stored in a
520
distributed
MB data
manner,
not stored in
and
single
we are
block. So
maintaining the
this can be
replica of the
divided
data.
into
Okay.
partitions.
So what is the
Divided
replication
into the
factor?
number of partitions.
That is
So
3.
here in
Okay. Even
first
one
partition
data node
we
is
have to store
crashed,
128
we
MB.
can retrieve the
Okay.
same block
So
from
here 128
another
MB data.
data node.
Here 128
Okay.
MB data.
Right.
So like
that
that
is
we are
fault
going
tolerance.
to store the
So
data.
our Hadoop system will ensure
Block
fault
size.
tolerance.
Next
And
name
coming
node.
to
So
scalability.
name node is nothing but
So what is
it
scalability?
is the store the metadata.
What is
Store
scalability?
the metadata. Okay. All the file names, file
What
sizes,
is
file
scalability?
permissions must be stored in
So
the
every day
name
data
node.
is increasing
Okay.
exponentially or
Next
not?
one is the data nodes.
Right.
So data node
So
is known as
now,
the
right, big data is right now. Big data is
worker
handling.
node. This is
Right.
the
So
worker node.
petabytes or
So here
exabytes of
name
data.
node is the master
Okay.
node. Data node is the worker
Right.
node. Okay.
So
in
every day, like
in
the
one
data is
HDFS
increasing
file, we
exponentially.
have only
We are
one
getting
name node
data from
and
social media. We are getting
2
data
or
from
more data nodes we are
nodes,
going to have.
sensors,
Okay.
IoT,
So here
right, mobile
like
applications,
this. So
right.
this is the name
So
node.
what not, right? So every day data is increasing
This is the
exponentially.
name
So
node,
that means
or
we
it
need
is also known
additional
as the
storage,
metadata.
additional
Metadata,
processing
a secondary name node.
capabilities, right?
So these are the
So
data nodes.
even though data is
These are
increasing
the
exponentially,
data
we
nodes.
can accommodate, we can store the data, right?
Okay.
So in a
So here this data node name is
in an efficient
A,
manner. So
and
that
this
is
is the
what
B,
scalability.
and this one is the
Okay, we
C.
can store the data, we can process the data. Okay.
Listen,
So basically, like if you see
this is
the
the
input
name node,
files,
and these are the
so
data
the
node,
input
data
files
node,
of the
data node.
HDFS,
Okay.
so which
here
are split
file
into
name is the data
blocks.
node is A, and
Okay.
data node is
What is
B,
the block
data
size?
node
Default
is C.
block size is
Okay. Here the
128
file name
MB.
is A,
Right.
file name is B,
So
file
these
name is C.
blocks
Okay.
are
Same
stored
file is stored in
across
another
different
data node also.
machines.
Okay.
Right.
Same
Now the
file
question
is
is,
stored in another
why
file also.
the block
Why?
size
Because
is 128 MB?
is
Every block
if
size
this one is listen, if this one is shut down,
Why
or
the block
data
size is
is
128
unavailable,
MB?
or server is unavailable,
Why don't we
so
maintain,
we need to take
right?
data
So
from
why
the
don't we
another
have
data node.
block size like
Okay.
100 MB,
So how it
256
is
MB,
possible
like
by using the
random
name node.
sizes?
Okay. So name node knows all the file name, file sizes, file permissions, all this stored
So
in the
what is
name
Hadoop?
node.
Hadoop definition
Okay.
లోనే ఉంది.
So
What
this
is
is
Hadoop?
known as the replicas.
Distributed storage and
This is known as
right
replicas. In
Okay.
one
To store the
HDFS,
data
how
in a
many
distributed
replicas
manner
we are
and
going to have?
process data.
3
We need
replicas
a
we are going
common
to have.
format.
Okay. How many
Because we
replicas
are
we are
dealing
going
with
to have?
huge
3
amount of
replicas.
data.
Okay, next one is the
Hadoop is
MapReduce.
storing
So
huge
MapReduce
amount
is
of
nothing
data.
but this is for the
So we
data
need a
processing
common
purpose. We are
format
going to
to
use
store and
MapReduce.
process the data.
Okay,
So
data
that is the
processing
reason the
purpose.
block size is
Here in
128
MapReduce,
MB.
we have
Okay,
mapper
right.
is one
So
function and
where this data
reducer
is
is
going
one
to be
function.
stored?
Mapper is one
Across
function
cluster of computers.
and the reducer
So
is the
that computer is
one
nothing
function.
but data
So
node.
what
Data
is
node
the
is
use
nothing
of
but a
mapper
machine.
function is nothing but
Okay,
mapper function
right.
is
So
used
each
to
block is
key value pair
replicated.
purpose.
Each block
It
is
is key
replicated.
value pair purpose.
So
We are
what
going
is
to
the
use
size
map
of the
function
right?
and the reduce
What is the
function is
replication factor?
this is the aggregation kind of the
3, right? So
aggregation kind
same
of
block
operations it is going
is
to
going to be
perform.
stored
Here
in the
reduce
3
is nothing but
places, in 3 different
map is
places.
the key value
Okay,
pair and reduce
right.
is the
So these basically these are designed to
merging
write
all this
write once and
at
read
the
many
time of the
access kind of
result.
mode. Okay,
Understood?
and
What is the use of map
why
function?
HDFS is
Map,
needed
map
basically?
function can be used to
What is the
generate
problem with the traditional
intermediate
systems?
key value pairs, whereas
Right. So
reduce
traditional systems
function can
cannot
be used
handle
to
petabytes of
combine
data, large
all the
amount of
these key
data.
value pairs.
Okay, and
Nothing but merging.
our
This
traditional
is for
systems which may
merging purpose
fail
we are
when
going to
disk
use.
crashes.
Okay, so
Okay,
here in
because in the
HD
traditional
in
systems
Hadoop,
like in
HDFS and
RDBMS or
MapReduce can plays an important
basically the
role.
data is
Okay,
going to be stored in
so
only
because
one
of
server
this HDFS and MapReduce,
or one system.
Hadoop
If
can
that system
provide
is crashed,
scalability,
right, so
reliability,
entire
and
data
fault
is
to learn
lost only.
services.
Okay,
Okay,
and
understood?
the traditional systems are
How
expensive.
this is
Okay,
provides
so
scalability,
whereas compared to
reliability,
Hadoop,
and
Hadoop
fault
is
tolerance
using commodity
because of the
hardware,
HDFS
and
and
traditional systems
MapReduce.
are like
Because
they
of
are expensive.
HDFS
So
and
what is commodity
MapReduce.
hardware, Nana?
Here,
Hadoop is
HDFS and
using,
MapReduce
right?
designed to continue the work
Hadoop
in
is
case of
using
system failures.
for basically to store and process
Listen
the data.
carefully.
For this, it is using
HDFS and
hardware.
MapReduce
What
designed
kind
to
of
work,
hardware it is using?
designed to
It
work,
is using commodity
continue to
hardware.
design to work in case of system failures. Okay.
Commodity hardware.
Here
So what do you mean by
HDFS is
commodity
the
hardware?
primary data storage and
Cheap
MapReduce is the
hardware.
data processing purpose. So next of all, next is the
Okay.
YARN. YARN
So
stands for
these problems, like the
YARN
problems
stands
which
for
are facing in the traditional
yet
systems,
another
is handled
resource
or overcome by
navigator.
using right HDFS. Okay.
What is
So
YARN?
HDFS handles
YARN
hardware
stands for
failures automatically. Okay. If one
what is the
system is
use of
crashed,
YARN?
then we'll replace that system
So it
and
is
runs
the
on low
resource
cost commodity
allocation
hardware.
purpose.
Right. That is what
Resource
cheap hardware
allocation
we are
purpose we
using,
are going to use
and
YARN.
it uses
Resource
big
allocation
data
purpose
workloads.
we are going
So
to use
basically,
YARN.
Hadoop,
Okay, and
Apache
along
Hadoop is
with
designed for
HDFS
right to
MapReduce
handle
YARN,
big data like
next we
storage
are
and
going to have
processing. Okay.
one is
So we have
HBase.
seen the like
HBase
architecture
also.
of HDFS,
Okay, so
right?
what is the use
So
of
what are the different
HBase?
nodes are there in the
What is the use of
HDFS?
HBase? HBase is the
Right.
non-relational
So name node.
databases.
The first node is
HBase is
name node. So
non-relational
what is name
database.
node?
Okay, a non-relational database, and
What
it
is
is
the
the
functionality of name node?
column-oriented database.
Right.
Column-oriented
It stores
database.
meta data.
ఏంటమ్మా మీకు
It stores meta data. Okay.
ఏంటి చెప్పండి
So
మీ
if you
ప్రాబ్లం ఏంటి
look at
చెప్పండి.
the HDFS architecture, so HDFS architecture
ఏం
basically
చేస్తున్నారా మొబైల్ మీరు అందరూ?
right, it consists of or it uses master slave
అరే రికార్డింగ్
architecture.
అనేది ఇప్పుడు కాదురా, మీరు ఇంటికి వెళ్ళిన తర్వాత
It
క్లాస్ ఏమైనా
uses
డౌట్ ఉంటే
master slave
అది అక్కడ రికార్డ్ చేసుకో,
architecture.
రికార్డ్ వినడానికి.
Okay. So why it is called master slave architecture? Why it is called master slave architecture?
అది డిలీట్ చేయొచ్చు మళ్ళీ ఏం కాదు.
Because the master node, right, is handling all the data nodes, all the slave nodes. Here the data nodes are nothing but slave nodes. What is master node? Name node. How many name nodes are there? Only one. Only one name node is there. And whereas coming to data nodes, if you look at this diagram, right, how many data nodes are there? How many data nodes? There are 5 data nodes. Okay. So who is right handling this read and write operation? Name node. Okay, name node take care of all the operations in the HDFS architecture. Okay, right. For example, um, client want to read the data from the data node. Okay, so what the client will do,
అరే
it will
మీరు
send a
సైలెన్స్
request to
ఉంటే
the
క్లాస్ అయితే
name
లేకుండా
node.
క్లాస్ క్లాస్
Okay,
వదిలేస్తా చెప్తున్నా.
right. So client, I want to read, it will say like,
అరే ఏం
I want to
మాట్లాడతారు
read
అసలు
data from the
డైలీ
data
మాట్లాడుతూనే
node,
ఉంటారు,
some X
ల్యాబ్ లో
data
మాట్లాడతారు,
node.
క్లాస్ లో మాట్లాడతారు. ఆ?
Now the client will give the request to the name node. What the name node will do,
అదే బిగ్ డేటా అనాలిటిక్స్
right? What is
సింపుల్
the name
సబ్జెక్ట్,
node?
జస్ట్ క్లాస్
Basically
వింటే
what it
సరిపోతుంది, మళ్ళీ
consists,
మీరు వెళ్ళి
right? It consists
ఏదో
of
బుక్స్
metadata.
రిఫర్ చేయాల్సిన
Name
అవసరం
node
లేదు.
will have metadata. So what do you mean by metadata? Data about data.
చార్ట్
That
జీపీటీ
means,
ఎవరు ఫాలో అవుతుంది,
so
ఇచ్చిన
it
పీడిఎఫ్
contains
ఫాలో
information
అవ్వాలి.
about the name
ఆ
of the
పీడిఎఫ్
data
ఉన్న
block,
క్వశ్చన్లే
right?
మీరు
The
రీడ్
replica of
చేయండి.
the data block, how many
You know?
copies of the right data
And
blocks are
yesterday
stored
I
and
given
where it
some
has been stored.
questions, important questions,
And
short
this
answers
like
questions.
hash
Any doubt in that?
slash home slash foo slash data, it's nothing but path. Okay, where exactly the
Are
data block is
important
stored.
questions, and I will
Okay,
send out
so this
long questions
information
also.
is stored in the
Okay.
name node.
So third
It is
unit నుండి
maintained
one
by
question
the
వస్తుంది.
name node. Okay, so now the name node
Second,
will give
first
the
unit,
exact
second unit, and
block
third
position,
unit.
where is the data block, and the path also it will be specified. And now the client will go to that particular data node and it will start reading the data. Similarly, right, write operation. Okay, so basically the data is going to be stored in the data ekkada store avutundana,
Okay.
data is stored in the
Next topic is
data is
the
stored
Apache
in
Hadoop module.
name node or data node,
Apache
stored in
Hadoop
data
module.
node. Okay, so our original data that is splitted into blocks. Okay, so these blocks is stored in the data node. Okay, right. So next, coming to if you see the real time example,
Apache
like
Hadoop
social
module.
media image storage, right? How this social media image is going is stored in HDFS.
In Apache
Okay,
Hadoop module,
so for example,
the first
let's say
one is the
Facebook.
Hadoop
Okay,
common.
so there are billions
Hadoop
of images
common.
uploaded by the users. Okay,
Hadoop
now like
common is
Insta,
nothing but, so this is
we are uploading some different videos,
this Hadoop
right,
common
images,
include
right,
the common
some kind of
utilities.
information.
The
So
common
these are the billions of
utilities.
images which are
Here
uploaded by the
we are
users
going
in the
to
Facebook.
use the language Java.
So now
So
the thing
Java
is,
utilities,
right,
we have
how
to
this
need the
image
basic
is
knowledge
splitted
of
into
the
blocks.
Java.
First,
Okay, how we are
each
compiling
image file
the
is,
Java program,
right,
how we are
if
run
you
the
want to
Java
store in
program.
HDFS,
So
what we have to do,
basic the Java
what the
libraries we have
Hadoop
to
will do,
know. Hadoop
what the
common.
Hadoop will do.
Next one is the next module is HDFS.
ఏం చేస్తానన్నా?
Hadoop distributed file system.
Before
So
going to
just
store
now
the
we
data
discussed.
into HDFS,
Next one is
that
next
splitted
module
into
is the
blocks.
MapReduce.
So each image file of
MapReduce.
the Facebook, these billions
This is
of
also
images,
completed.
right? These are
HDFS is
splitted
the
into
data storage,
blocks.
and Hadoop
Okay,
MapReduce is the
so blocks stored
data
across
processing purpose
multiple,
we are going to use.
right,
Next module
systems
is the
or
Yarn.
servers or
So
cluster of
Yarn is
computers.
nothing but, so this is
Okay,
resource allocation
right.
purpose.
If one
And
server
job
fails,
scheduling purpose we are
or
going to
if
use
one
Yarn.
data node is failed,
Job scheduling
right,
purpose.
so
Next one is
replicas available in the
Cassandra. Next module
replicas
is
available so
Cassandra.
that we can retrieve
So
the
Cassandra
data,
is nothing but,
right.
so this is for
So users can still access
SQL,
images without interruption
data,
because we are storing
DBMS,
data in a
database
distributed manner.
management, database
Okay,
management system.
so for
Here
MapReduce
we are
framework,
going to
what
store
the
the
MapReduce will do,
unstructured
okay,
data. Unstructured data.
MapReduce is like it's a
Here we are
distributed,
going to use
right,
unstructured data. Why?
processing,
Because the
parallel processing
90% of the data is
programming, right.
unstructured data.
So
The data
this
which is
like it is
created,
used to
which is
process large data
analyzed,
set,
so the data
sets
is
stored
unstructured
on
data.
HDFS.
Only
Right.
the
As
10%
we know,
of the
it
data
consists
is
of two
structured
phases,
data. Remaining
phases.
all
One is
90% of
map
the
phase.
data is unstructured data.
Second one is
So here
reduce phase.
Cassandra can
Right.
can also
So
use
map
to
phase ఏం చేస్తుంది? Like it will
the
take the data from the
huge
HDFS,
amount of the data.
right? So it will generate intermediate results.
Cassandra can be
So
used
the
to store
intermediate results in the
huge
form
amount
of
of the
key
data.
value.
Then after
So మన
HBase.
images ఏం
So
చేసాం మన?
HBase is the
Like the images
non-relational
are, these
database
billions of
management
images
system.
are splitted into
Non-relational
blocks.
database management
Okay.
system.
So these
And
blocks are stored
so
in a
here, this
right
one is
within
column
cluster of
oriented
computers in a
database.
distributed manner.
Column
So from
oriented
that we are
database.
taking that
And
input,
it is
those
also provide
images in
the
the form of blocks, and these are
scalable
converted into
services.
key value
Scalable
pair.
services. Next one is the
Okay, so
Apache
key
Spark.
value pair kinda
Next module
right
is
convert
Apache
చేస్తుంది.
Spark.
And
Apache Spark can
these key
also be
value pairs
can
will be
use
given
to
as input to the reducer.
real-time
So
processing
reducer
purpose
will aggregate
and
intermediate
ETL.
results and produces
ETL stands
final
for
output. So
ETL.
final output మళ్ళీ ఎక్కడ
Extract,
స్టోర్ అవుతుంది? Again it is going to
transform,
be stored in
and
the
load. So Apache Spark
HDFS.
also can be used to
Okay,
store the
right.
huge amount
So
of the
it
data
also
or
perform like
the
task
vast amount
scheduling,
of the
right?
data, and it is
Uh,
provide the real-time processing and ETL services, and also it can be used to
right, the
machine
data
learning.
distribution, fault tolerance,
Also
everything
used
is
to the
performed.
machine learning.
Right.
Next one
So
is the
this
Hive. Hive
this
is nothing
this
but
diagram will shows how
next
basically
one is Hive.
MapReduce
So
framework works. Okay.
we know SQL,
Basically,
structured query
right,
language.
the input
Here
files.
in
First
Hive
step
we
ఏంటన్నా
have
input files
HQL.
are split into
HQL stands for
blocks.
Hive Query
Okay.
Language.
So
Hive
here,
Query
right,
Language.
input like in the HDFS.
So this
The
is
input file
summarizing
are
purpose,
split into blocks, split
summarizing
0,
purpose,
split
and
1, split 2.
analyzing purpose, querying
Okay.
purpose.
Right.
Summarizing,
So every for every split,
summarizing,
okay.
querying, and
So one
analyzing
mapper is
purpose. We are
assigned.
going to use Hive.
Okay.
So next one is
One
the
mapper is
pig.
assigned. Right. Split 0, one
So
mapper,
pig,
split 1, one mapper, split
pig
2,
is nothing but
another
so here
mapper. Okay.
the variety
So
of the data is
after
nothing but we
processing
have
the
structured data,
mapper ఏం
unstructured data,
చేస్తుందన్నా?
and semi-structured
It will
data.
generate
Here
intermediate
pig,
results.
as pig
Right.
also used
So
to
what are
store
those
any
intermediate
kind of
results?
data, either it is
It's nothing
structured,
but key
unstructured, or
value
semi-structured
pairs.
data. It is
Right.
used to
So
any kind of
these key
data.
value pairs,
And here
right,
the
will be
language
given as input to
used
the
in pig is that is
reducer.
pig Latin.
Okay.
Pig
It is given
Latin.
as input to
So
the
here the
reducer.
user
So
cannot
reducer
have
ఏం
any
చేస్తుంది?
knowledge,
Right.
cannot
It
require
will
any
sort and
programming
aggregate the
language.
data and will produce the
If we want to
final
work with
result.
HDFS
So final
MapReduce
result ఎక్కడ store
compulsory,
చేస్తున్నాం మనం?
we have to require
Again in
the
the
programming language.
HDFS.
Programming
Right.
language.
So
But
the best
if
example
we
is
want work with
right.
the
We
pig,
have input
we
file.
don't require any
The file
programming
is like
language.
this.
We
Right.
don't require
Deer, bear,
any
river,
programming
car,
language.
river,
So
deer,
then
car,
after
deer. So
Scoop.
this is the input file. Just
So Scoop
illustrative
also
example.
one of the Apache
Okay.
module.
So this
Scoop
is
also
splitting.
one of the
This is
Apache
splitted into
module.
blocks.
So this is for non-relational
So
database
ఏం చేస్తున్నాం
management system
మనం?
purpose. We are
The
going to use
first
this
line,
Scoop.
right,
Okay.
one block.
And it is
Second
a
line is
command line
another
interface.
block. Third line is another block.
Okay.
Okay.
It is a
For
command
each
line
block,
interface.
what we
Next
are
one
doing?
is the
We are assigning
Zookeeper.
a mapper. We are assigning
Zookeeper
a
is nothing but
mapper.
already you know in
Okay.
Apache Spark.
So what is mapper? What is the
Apache
functionality of the mapper?
Spark. What is the use of
What is the
Zookeeper?
functionality of the mapper?
So Zookeeper can also be used
It
to.
will produce intermediate
It is the
results. The
synchronization
results are
purpose
in the
we are
form
going
of
to use
key
Zookeeper.
value pairs.
Synchronization purpose.
Okay. So
These are the
from this split
Apache
1 or split
Hadoop
0,
modules.
right?
Okay,
We
first
are
one is the
generating
Hadoop
key
common,
value
second one is the
pairs.
HDFS,
Okay.
next
That
one is the
means how many
MapReduce,
times
Yarn,
this deer is appeared in
next
that
Cassandra,
block,
HBase,
or bear
Apache
is
Spark,
appeared in the block, or
Hive,
river is appeared in the
Pig,
block.
Scoop,
So deer any
Zookeeper.
times repeat aydina na?
So these are
Only
the
one time. So this is key. Deer name is key, and how many time it is appeared in the block, that is value. Okay. So that is deer comma 1. Similarly bear comma 1, river comma 1. So similarly for this split, one more mapper is assigned, like car, river. Right. Again it is generating key value pair. The third split, that is deer, car, bear. Again it is generating key value pair by using the mapper. Okay. So now coming to the right intermediate phase, that is called shuffling phase. Okay. So in the shuffling, all the same keys are grouped together, which are sorted. Okay. So చూద్దాం ఇక్కడ, right? So we have, right, beer, right? So beer is there in the third split, beer is there in the first split. Okay. So these are grouped together, beer 1, beer 1. Okay. Coming to the second shuffling phase, right? So we have car is appeared for 3 times. Okay. So car is here in the second mapper. Car is appeared for 2 times, and here 1 time, like this, right? All are shuffled. Okay. Now coming to the reducer. So reducer will aggregate the result. Okay, sort and aggregate the result. So beer is right, beer is appeared two times, car is appeared three times, and the deer is appeared two times, and the river is appeared two times. Okay, right. So now it will produce the final result. So our final result is how many times the beer is there in the given input file? Two times. Okay, so this is a best example for word count. Okay, what is this problem? This problem is word count problem. Okay, for example, we want to do the same, we want to process the word count, right? How many word frequency in a given file by using our traditional systems. So it takes a lot of time because we want to write process every word. What we are doing in Hadoop, simply we are splitting, right? Each split will be given, will be assigned with a mapper. Mapper is generating some key value pairs, right? Then the next step is shuffling, right? The next step is reducer will aggregate the result. So simply we are getting right final word count. Okay, so next coming to the log file analysis. So this is a real time example for word count problem. So for example, we have an e-commerce company. Okay, so that company analyzes server logs to find peak traffic hours. Okay, right. So ఎప్పుడు server మీద load ఎక్కువ ఉంటుంది. Okay, they want to analyze when the server is busy. Okay, right. So that they want to analyze. So for that, what it is doing, first logs are stored in the HDFS, that splitting of logs and into blocks, and these blocks are stored in the HDFS. The mapper task is extract timestamps, right? When that log is created. Okay, that information is extracted by using mapper. Okay, so the reducer task is count number of requests per hour. Okay, so 1 hour low any requests vachai. Okay, so that is done with the help of reducer. Okay, so output shows peak usage periods. Okay, so in which hour, right, there is huge traffic in the server, that information is right displayed or produced by the reducer. Okay, so the next Hadoop ecosystem component is like Hive or SQL querying. Okay, so basically, what is SQL, Anna? What is SQL? Structured Query Language. Okay, so can we use SQL in big data? Is it possible to use SQL with big data? No, because right, SQL only handles structured data. Okay, so we are using HiveQL. So this is also like querying big data uh, uh, from the warehouse, right? So basically it is a data warehousing tool. Hive is a data warehousing tool that allows user to query big data by using a query language called HiveQL. What is the query language it is using? Hive, right? It is using HiveQL. Okay, so basically the role of the HiveQL is it converts SQL queries into map reduce jobs. Okay, so this task is done automatically. Okay, the HiveQL
In
is
big
used
data,
to
there are
convert,
the four characteristics are there,
right,
four volumes.
queries into map reduce jobs
There are four
automatically.
characters are there in big data: volume, veracity,
Okay,
variety, and
and
veracity.
basically
Volume is nothing
mainly
but to
used
store the
by
massive amount of
data
the data
analysts,
which is created and
right? Business
generated
intelligence
from
users
various resources.
and users those are having
Veracity is nothing
SQL
but a
background.
speed,
Okay,
speed in which data is generated, analyzed, and created.
right.
Variety is
So the
nothing but
features of
structured data,
HiveQL is
unstructured data, and
right.
semi-structured data.
So we need not to write a more complex map reduce code, and it also supports structured data. It also write schema on read approach. Okay, right. So if you look at the architecture of Hive, okay, right? So JDBC, ODBC, it is in the top. What is JDBC? What is JDBC? Java Database Connectivity. Okay. So ఎక్కడ యూజ్ చేస్తున్నానా? Where the JDBC is used? JDBC is used with .NET or C or C++ or Java, right? So for example, you are creating a form, okay, login form. Let's say Gmail login form, right? When you click on sign up, so it will give all the details like a name, right? First name, second name, middle name, date of birth, phone number, right? So mail ID, that is available or not, that information also it will display. Okay. So when you click on create account, right? So where all these details is going to be stored in the database. Okay, in the Google database, right? So now we want to retrieve the data, whatever the information we have stored in the database we want to retrieve. Okay, how it is possible? We are using Java programming, for example, and we want to retrieve the data which is stored in the database. How to retrieve the data? How many of you done JDBC programming, Java database connectivity? Raise your hands. రైట్. సో వర్క్ చేసారు కదా మీరు అందరూ. సో టేబుల్లో ఉన్న డేటాని రిట్రీవ్ చేయడానికి, టేబుల్లో స్టోర్ చేయడానికి వి ఆర్ యూజింగ్ JDBC. ఓకే. So these are all like Hadoop ecosystem components. So one more component of Hadoop is like a scoop. So what is scoop, Nana? What is scoop? See, this topic already we have discussed, right? What is scoop? To transfer the data between RDBMS and Hadoop or HDFS. Okay, right. So to store the data into the HDFS or from HDFS we want to transfer the data to RDBMS server. So that is possible with the help of Scoop. Okay, right. So importing tables from RDBMS to HDFS or exporting processed data back to RDBMS. So that is nothing but transferring data between RDBMS and HDFS. Okay. Okay. So that is like parallel data transfer and JDBC connectors. What ASICs? Hello, Manas, what happened? Right. So this is RDBMS server. RDBMS, relational database management systems, like your MySQL, Oracle, right? DB2, anything. And whereas coming to here, right? HDFS, Hadoop, file system, right? HDFS, HBase, Hive. Okay. So in between these two, like importing the data or exporting the data, right, done with the help of Scoop. Okay. So these are the like components of Hadoop ecosystem. What is Hadoop ecosystem? What is Hadoop ecosystem? It's a collection of tools, right, that is used with the big data for processing, for storage and processing. Okay, that is Hadoop ecosystem. Okay.